Welcome to Study Loop.
This is the answer to Chapter 21, problem number 56 from the Smith Organic Chemistry textbook. And this problem asks us to consider two aromatic ketones. They're both para-substituted, and we're asked three questions that are comparisons between these two molecules. And so basically what this question boils down to is the NO2 group is electron withdrawing, and the methoxy group is electron donating. And so the answers to each of these three questions in this problem are going to depend pretty much entirely on those properties. So the nitro group is strongly electron withdrawing, and the methoxy group is fairly strongly electron donating. And so let's see. So we're first asked which carbonyl compound is more stable. And so the paramethoxy acetophenone is going to be more stable. So electrons are donated into the ring from the paramethoxy group. And then because the ketone is in conjugation with the ring system, it's stabilized by that extra electron density. And of course, in the para-nitroacetophenone, the opposite is true. The carbonyl is electron poor because the nitro group is pulling electron density from the ring. And again, the carbonyl is in conjugation with the ring. And so its electron density is being pulled away as well. And so it's going to be less stable. Okay. And so the second question that we're asked is which has a higher percentage of hydrate at equilibrium. And so again, electron withdrawing groups are going to increase the amount of hydrate at equilibrium and vice versa. So the nitroacetophenone is going to have more hydrate, and the methoxyacetophenone will have less hydrate. And knowing their stabilities, this should be what we would predict, right? Because if the methoxyacetophenone is more stable, it's going to be less reactive, and so it should have less hydrate. And then so lastly, we're asked about IR shifts. So which compound exhibits a carbonyl absorption at higher wave number in its IR spectra? And so an electron donating group is going to result in the lower wave number because, again, electron donating groups stabilize these molecules. And so the more stable molecule is going to be lower energy, and so that correlates to a lower wave number. And so we would expect the paramethoxy to have a lower IR peak, and we would expect the para-nitro to have a higher IR peak. Okay, and so that addresses the three questions that we were asked about these molecules. And again, the answers can really be found and rationalized just by invoking the electron withdrawing and electron donating effects of the ring substituents, and the fact that these carbonyls are in conjugation with the aromatic system. And that's the answer to Chapter 21, problem number 56.